Hello, Assalamualaikum everyone. I hope you are all fine. Today we will be discussing about some of the basics of IP address, and then we will look into the subnetting concept, and then we will see the subnetting through the help of an example. So let's begin today's lecture of this topic. Firstly, we need to understand what is an IP address. IP address is a logical address assigned to a device which is being connected to a network or a portion of a network. So IP address is used in order to uniquely identify a device which is connected on an IP network. So this IP address can vary as you connect yourself to another network. So this is basically a logical address which represents your identity uniquely whenever you connect it to a network. And there are two versions of IP address that are available. First is the version 4 and second one is the version 6. Version 4 is a 32-bit IP address, and version 6 is a 128-bit IP address. Usually 128-bit, which is with version 6, is not used, but our industry and our networks are being now shifting towards version 6, but mostly version 4 IP address is used. There are 5 classes in version 4 IP address, which can be determined from the 3 higher order bits in decimal format, and in the binary format, first 8 bits will determine the class of IP address. So class A IP address will start from 1. The first bit or the first 3 bits will identify the class of an IP address. If your starting bit is something like 1, and class A, it ranges from 1 to 1 to 7. Basically 1 to 7 is not used, it is 1 to 6. So then this IP address will be of class A, and class B IP address is 128 to 191. Class C is 192 to 223, and then you can see, and it will represent about the classes basically represent about the network portion and the host portion as well. So the total address space is 32 bits. For class A, there are 24 bits for network, for host, and 8 bits are for the network part. The network part means that 8 bits are there for routers or the networking devices to get their IP address. However, 24 bits are available for user portion, and class B has a balance of 16 bits for network and 16 bits for host. Class C has 24 bits for network and 8 bits for host, and then class C is a multicast group, and class E is reserved for future use. Then we have in IP address, there's a concept of network mask, which defines which portion it will determine which portion of the address identifies the network, and which portion will determine the address of the host. So class A has if any address of a class A comes, then it will have a subnet mask of something like that. It will show that 255 devices can be connected of an IP on an IP address of class A, and this will represent the remaining 24 bits will represent to be 0, because they will be used for host part. So subnet mask will determine about how many number of devices or how many number of bits are available for network part and for host part. So in class A, you will have a subnet mask, default subnet mask to be as 255.0.0.0 for because you have 8 bits for network. Then class B will have this type of subnet mask, because you have first 16 bits for network part and remaining 16 bits for host part. And class E will have a default subnet mask to be as like this. So subnet mask will basically determine about the network part and the host part. And then we have a concept of subnetting, which will subnetting will allow us to create multiple logical networks that exist within a single class of network, because we want to make our network to be divided into sub portions. For example, if you have a campus network and you want your network to be more manageable, then you basically create sub portion in the network. For example, you will create a subnet of CS host, and then will create a subnet of electrical engineering or the other department host. So in that case, subnetting case, if you are doing the subnetting, then basically you are dividing your IP address into smaller portion. So that will allow us to create multiple logical networks that will exist within a single class of network. So if we don't do the subnetting, then we will be able to use only one network from our classes, so which will be unrealistic. Subnetting will allow us to use the IP address space in a more efficient way. And in order to subnet a network, we will extend the original subnet mask with some of the bits to be borrowed from host portion of the address in order to create multiple subnets. So how we will do that, we will look at this through the help of an example. So assume that you are giving address of this. I have represented in this in a format that you have an IP address of 192.168.1.0, and /24 means it is a classful IP address of class C. So now it means that 24 bits are for network part and remaining 8 bits are for host part. So in order to create multiple subnets, if we don't create multiple subnets here, by default we will be having only one network. So all our hosts will be using the same network. However, we want our whole network to be divided into sub portion, because there are users which have to be categorized. So we will do the subnetting, and in this example we will create two subnets from this IP address, and then we will determine the new subnet mask and the starting IP address of each subnet. So how we will do that? So first step is that we will convert the original subnet mask into the binary, which is the original subnet mask of this class C IP address is something like that. And then the binary conversion of this comes out to be this. So we have converted our original subnet mask into the binary. So now the requirement is that we have to create two subnets. So that means we have to determine the number of bits that are to be borrowed. So the formula for creating the number of subnets is something like that, which is 2 raised to power n, and here n will determine the number of bits that are to be borrowed from the host part. So in this case we need two subnets, which means that we need 2 raised to power 1. So means one bit has to be borrowed from the host part. So we have identified the number of bits in the second step. So if you are creating two subnets, then we need only one bit to be borrowed. If you are creating 4 subnets, then you need 2 bits to be borrowed. So in this case we need only one bit to be borrowed. So now let's borrow the 1 bit from the original subnet mask, which is this one. So we will borrow 1 bit. So our new subnet mask will be like that. We have borrowed the 1 bit. This is the 1 bit we have been borrowed as compared to this. So we have borrowed our 1 bit from the original subnet mask, and now our new subnet mask is something like that, which shows that we have borrowed the one bit from original subnet mask. So now we will represent this IP address in the classless interdomain format, which that we have borrowed one bit. So we have borrowed the network part has now come to be out to be 25 bits, because we have borrowed one bit, so there are 25 bits. So this is our IP address in the CIDR notation. So now we have to determine how many hosts will be in each subnet. So that means there are remaining 7 bits in the host part. So formula is 2 raised to power m, so it means that 128 hosts are in each subnet. So the starting IP address of subnet 1 will be 192.168.1.0 to 1.127. So in this case, the 1.0 is the network ID and 1.127 is the broadcast address. So these addresses will not be used for host, but it will be used to represent the network part and the broadcast address. So similarly, the subnet number 2 will be having the starting IP address of 128.2.2.5, and in this case 128 will represent the network ID and 255 will represent the broadcast address. So that's how we will do the subnetting, and this is the fixed length subnet mask, or you can say the fixed length subnetting. We also have a concept of variable length subnet mask as well. So let's summarize this subnetting into a chart. So if you are using if you have borrowed one bit in order to create two subnets, so the number of subnets in this case in the first column are 2. So it means you have borrowed one bit. The format for representing the IP address will be /25, and the subnet mask will be for this is the subnetting chart for class C only. So the ending number in the subnet mask will be 128. This will be the our subnet mask 255.255. Then we will have this value to be here, in this case 128, and the number of hosts are here to be 128. So the number of subnets are 2, and in this case if you are borrowing the 2 bits, that means you are creating 4 subnets. So the slash format will be /26, and the subnet mask will be 192, and each subnet will have 64 hosts. And if you are borrowing 3 bits, that means 8 subnets you are creating, and then you have a subnet mask to be like that, and each subnet will have 32 hosts, and you can see that. And this table is only for class C IP address. Yes, this can be used as a yardstick to calculate the subnetting chart for class B or class D as well. So that's all for today. That's all about the IP address and the subnetting. Hope you have learned very much from that. Okay, Allah Hafiz for now.